All right, we will get started in just a moment. We'll do a little bit of housekeeping, audio alignment, and the like. All right, Joe, I'm hitting my record button and clap. Okay, go ahead.
There you go.
Hello and welcome to Enterprise Linux Security, episode 97. I'm here after a bit of a summer break with my friend Joao. How you doing?
All good, Jay. As always, a pleasure being back after these weeks. Hope you got some rest and relaxation going because we have some interesting stories to get back into. And yeah, who could have guessed? It's like we never left. Systems are still just as insecure as they were before.
Imagine that. No one's took our advice while we were gone, I guess, and maybe the number would have went up half a percentage point. So we're going to talk about a number of things today. We have, because we were trying to deliberate before the podcast, the best way to say this, because it looks good on the thumbnail, but saying 0.0.0.0 dash day just doesn't really have a ring to it. So we came up with quad 0 day. So this is a 0 day, but it's in regard to the IP address 0.0.0.0, which we will elaborate on further if anyone doesn't know what we're talking about. And then we have a couple of things from CISA. They're warning us about two things. We'll let you guys know what it is and whether or not that's something that you need to pay attention to, and some other stories.
Yeah, we have a few stories to get through today. Stuff that happened earlier this month that we feel it's relevant and everybody should be aware of them, and as such, we're bringing them to you.
Yep, so that's what we're doing.
As you were saying, we're going to start with the Quad Zero vulnerability. As always, funny names just keep coming. And this one, it's not like it's something new. This is a rehash of something that has been around for, they mentioned 18 years in the report. I believe it's probably more than that. Yep. Probably ever since the first web page was written and somebody included a link to localhost there and somebody else visited the web page. Yep. Basically, it's the same concept of what's happening there, but it touches on a few different aspects and it's relevant for system security for a few other different aspects that we're going to cover. And it has the particular feature of not affecting Windows. So if you're running Windows systems and you're feeling particularly happy right now, just wait until the end of the episode. We'll get to you at some point.
I sure will.
Okay, so
yeah. Go ahead.
Let's go over the vulnerability, give you a bit of a rundown of what the problem actually is. As you're likely aware, there's a set of private network addresses that's the same for everybody, and then there's the public IP space. Browsers have for quite some time now, a few decades, have some built-in protections that prevent a web page from a given website, say attacker.com, from opening an address that starts with 127.0.0.1, which is the local hosted IP address. That's to prevent that website from reaching local resources that you might have on your machine. That would be bad on so many levels.
Oh yeah.
As such, web browsers have developed and have implemented a few different protection schemes to get around that. One is called CORS, Cross-Origin Request Sharing. The other one is PAN, which is Private Access Network, Private Network Access, something like that, Private Network Access, something like that. It doesn't really matter to the story. What those features do is that they try to prevent those websites from reaching those resources that are stored locally, and they do so at different points in the connection. CORS will let the request go out, but will then block the response. So that in itself is one layer of protection. Even if you have a malicious script on a website and it tries to open a given port on your local host system, it will block the response from reaching the browser again. So it will try to prevent something like this. The other one is that there's a protection on websites from opening resources on private IP address space. So if a website has a URL that points to 192.168 something something, it will be blocked by the browser. It won't let the request go out. The vulnerability that was disclosed is around 0000, the quad zero address. because there isn't a standardized way of considering that address as part of any of the other two protection schemes that I just mentioned. So basically, browsers don't have a defined way of handling that address. And it was found that if a web page contains a URL that points to that address specifically, the request happens. And that's really bad because it circumvents the protections that the browsers have, and it's basically an oversight. What point is there in protecting from reaching the loopback device 127.0.0.1, but then you let them actually get there through 0.0.0. So that's a problem.
And the idea here, for anyone that's not already aware of this, the 0.0.0 quad zero, I'll just say that, has more than a few meanings. It refers to local host. If you're setting up a web server, if it's listening on 0.0.0.0, that means all network interfaces. So it's not quite the same thing, but it's effectively the same thing as turning your device into a router. So if your desktop was hit by this, your desktop then becomes a router to everything else, because your desktop, if it responds to 0.0.0.0, any other networks that are accessible to that desktop would also then be accessible by the threat actor. So it's kind of like a one of those things, when you think about it, it's like, well, that doesn't sound all bad. But then when you read it, you're like, oh, okay, that gives them like a whole menu of different things that they can do on your system. And remote code execution is just the beginning.
Yeah, there's actually a whole series of things that can go wrong after this becomes public.
Yeah.
First, and this has been possible for some time now, you can be fingerprinted before even you do any interaction with the website. Suppose that the web page that you're trying to open has an onload event that triggers some JavaScript and it does a port scan on your system. Because it's trying to hit 0.0.0.0, and I keep repeating this, it should be just quad zero. Because it's hitting quad zero, the request will go through and the website will know which open ports you have. This is particularly important because websites, one of the things that they really, really want is to know who is trying to open the page. For advertising purposes, they can identify you even before you start your login session, even before you type in your credentials. They can fingerprint your system and they know, oh, this is the system I've seen before. It has this amount of open ports and this many closed ports, and it has this screen resolution and it has this amount of browser extensions installed. And I can actually pinpoint that user pretty well. This is just an added data point that they can use to actually identify specific users of their website. And this is even just before any interaction that you have with the website.
And one of the things that was brought up in the article was, it's not enough to block the request. The request shouldn't have been made in the first place. And I think that can kind of help understand the issue here. If you're in a store and your phone tries to connect to the network, they could fingerprint you before you connect to any network because your phone made a request, right? Obviously, that's a different thing. But when you have a request to 0.0.0.0, there should be a way where that request shouldn't have been made. Even if it's being blocked on the other end and nothing happens, the fact that a request has been made, it's out there. And then that's why they could fingerprint, because the request is made. And based on that request, then they could find out more information.
Think about the amount of vulnerabilities that are out there for many different services, which are just malformed URLs. If you let your web page try to open that malformed URL and you happen to be running that service, it doesn't really matter the response. The attack already happened. If it's, for example, a URL that causes a specific service to crash and the malicious website tries to open that and you happen to be running it, it will crash the service regardless of any response that gets back or not. Just the request itself being made and being successfully hitting the target destination, that's enough to cause problems. Then there's another issue. There are lots of services that you deploy that you don't want to be network reachable, so that you just bind them to the loopback device, the loopback IP address, and you're not expecting it to receive any network connection. If you're opening a browser and the browser initiates that, it comes from the same device. So it's not coming from the network and the connection will be successful. So you will be receiving hits on services that you're expecting not to be network accessible. That's a problem. That
It
bypasses
is.
firewalls, it bypasses everything. That's really an issue here. Then there's just the services and the applications that implicitly trust localhost connections. There are many services that when they are deployed, they will immediately accept localhost connections, but not network connections. Sometimes you don't go through the hassle of changing that definition because that suits whatever you're trying to do. So you leave them at default settings. So it's very easy to find potential targets for this type of vulnerability, and that's why this has started to make the rounds again. This is really serious, and more so than it looks at face value.
All it would take, if I'm understanding this properly, is malvertising. Somebody could visit a website that is a perfectly fine website any other time. Somebody internally to the company said yes to the wrong ad, and there's malvertising on the ad. And next thing you know, I would suspect malvertising will be looking for quad zero at this point.
I mean, everybody knows that it's very difficult to get people to click on malicious links, right? So now they open a perfectly valid web page, a perfectly innocuous looking web page, and in the background it's running JavaScript and it's trying to do fingerprinting, it's trying to see whatever is running. If it happens to find successful services, it might be able to exploit them. It's basically, you might have the best perimeter firewall in the world, it won't block this. It's coming from inside the house, it's coming from your own machine.
I'm trying to find the versions because I remember somewhere in the article it mentioned that there's a fix in place for Firefox, Chrome, and the like, but the Chrome fix to be fixed fully will take a few more versions. But if I'm correct, I believe they mentioned that Quad Zero is being blocked on those browsers for now. And it sounds like they didn't word this very clear that they're going to reassess this and do a more appropriate fix, but for now, block that IP address.
Yeah, it appears that Safari is already blocking this, and Chrome is starting to roll out the change that will make it so that all Chrome versions will block this. But it started the rollout with version 128, and they're planning to have this completely rolled out by 133, which is weird why such a change takes 5 different versions to reach everybody, but it does. And it's also interesting that the response from Mozilla, the Firefox company, is that, yeah, this isn't a bug nor a feature. This is like this by design. So, yeah, who knows if they're going to block it or not. I believe they're just waiting for a standard to be defined. Since this address is not defined as part of the private address space, they're not including it into whatever protections they have until such a definition is made, until the standard is completed and all browsers abide by it. I don't know.
That seems irresponsible to me on
To
the
say
part
the
of
least.
Mozilla, because just because it's by design does not make it okay. I feel like I shouldn't have to tell Mozilla this. I feel like they should know this already, and it's kind of weird they would say this. It's the fact, from what I've read, it's kind of a spec, but kind of not. I mean, there's documentation, but there's no agreed upon method of not having this happen, other than saying you shouldn't have it set up to respond to quad 4 or quad 0. So it's like, okay, they're strongly suggesting, even though there's no protocol requirement to block this, but they're strongly suggesting you should. And they've been suggesting this for a while now for Mozilla just to say, well, it's by design. That doesn't sound by design. That sounds like there's a design and a strong implication that you shouldn't have that open. That strong implication should have been enough to make them fix it, I think.
Yeah, they're probably going to have to revise that position, and they'll have to start blocking it like all the other browsers are doing. I would just wish they did that sooner rather than later. Okay, so let's look at the next story that we have for today. We're very fond of bringing you guys surveys and survey information and all of that. This time I promise it's light. There is just one data point in one survey that I found amazing. There's this Uptime Institute's Global Data Center Survey 2024. I mean, what the survey is, it's in the title. It's a survey on data centers and how they are used and how they're implemented and the practices in the data center. And there is this amazing piece of information contained within. If you've been following IT, if you've in any way been doing anything IT related in the past 10 years, 15 years, 20 years even, there's this narrative going around that everything is moving to the cloud. all the companies are running cloud services. If you're not running your stuff on the cloud, you're missing out. And yeah, you should be thinking on ways of how to get your stuff on the cloud.
Mm-hmm.
It turns out that, I mean, there's an actually there, and it really is. The vast majority of workloads is still being run on premises. Okay, wrap your head around that for a minute. 45% of workloads are still being run on on-premises data centers, followed by colocation at 18%, and then the rest is divided between clouds, hybrid clouds, APIs, the works. But 45% of the workloads out there on different organizations of different sizes are still being run on premises. Why is this so catchy? Because of the bandwagon effect. We talked about this on the last episode for a different reason, I believe. But the thing is, sometimes, most times, companies don't really have a very good reason on why they are moving to the cloud. They are moving to the cloud because all the other companies are also on the cloud. So if they're there, I want to be there as well, even if I don't really know exactly why I want to be on the cloud.
Right. They're all reading the same white papers, basically.
Yeah, but apparently
Yeah.
that's not reality.
Right.
Now, I'm not trying to say that the cloud isn't useful. You shouldn't have stuff running there. It's not something that right now it's critical for whatever is happening everywhere on the internet. But if you're in a hurry to move to the cloud, if you're just doing it because all the other companies are, if you don't have an actual need for your specific workload, for your specific case, to use some type of cloud facility, some type of cloud platform, then by all means, you're not alone, you're not missing out, and you shouldn't be in a hurry to move just because. First, make sure there's a need, then do the move if that's what you actually find yourself in that position. Otherwise, like most other companies, man, on premises is still going great.
It is, and I really enjoyed this article because I agree with this. So it's selfish, but I've always felt this way for a long time. And the part of you mentioned bandwagon, and this is part of the industry that drives me crazy because and I don't follow any other industry obviously as well as I follow this one, but IT analysts are almost always wrong. It's incredible. Like in Michigan, you don't even know what the weather's going to be. Okay, the weatherman doesn't even know what to say. It's like when you have situations like this where you have bandwagons. It's like everybody wants to be on the bandwagon, but the bandwagon never works. IT analysts are always wrong. They keep their jobs. Meanwhile, the weathermen are the only ones that are almost as wrong here. Like if analysts were right, we'd be using netbooks right now. Now, I will say that there's probably more netbooks being used in my audience than most because, the Linux community, we keep things running and we appreciate our technology. But analysts said netbooks are going to replace all laptops. How many people do you know that has a netbook? I mean, sure, that's one thing. Then they say everything's moving to the cloud. Then they say everything's moving to containers. Not one time have them been wrong. And my personal favorite, and this was repeated by many IT analysts over the last 10 years. Every year they say DevOps is dying and it's going away. And every year they're wrong. So here, when you have everything's moving to the cloud, I just don't see it that way because one, it's another bandwagon, but two, think of it this way. I get a lot of requests for videos on my channel, so I can mirror the request to reality pretty easily. So when I'm reading this article and it's talking about hybrid cloud, so you have a physical data center, you have a cloud operation as well. That's a hybrid environment, and there's people asking for that. There's still people asking for tutorials on physical hardware. So at no point did the request that I receive mirror what the analysts are saying is happening. It's always the opposite. And then this article is like, well, yep, that's exactly what it's like. I get a lot of requests for hybrid cloud. And the thing that I'm going to tell everyone is nothing is moving to anything, period. I don't care what the technology is. It's never going to be the case that any solution is 100% effective for everything. You're always going to have an edge case. And if you don't think you're going to have an edge case, then you must be new to IT. There's always going to be an application that doesn't work in a VM for some reason it has to be on physical hardware. Something can't work in a container, so it has to be on a VM, or maybe something costs too much to run it locally. So they put that one thing in the cloud, but they leave everything local. And I think the thing that a lot of people don't really spotlight is the cost of cloud storage. I've seen companies with 20 terabytes in the cloud, and they're a hybrid cloud. So I'm thinking, why are you spending all that much money to store your data in the cloud when you have a hybrid cloud and then you have like a $20,000 or $30,000 bill? It's insane. So no, I guess that's a long way of saying that rant was a long way of saying that it's just never going to be the case that anything is good for everything. I just have a thing against bandwagons, I guess.
But this becomes more insidious than just that, I would think. First, because analysts are trying to create a self-fulfilling prophecy. If they say that everything is going to be moving to the cloud, they're trying to get people to move to the cloud, and then after some time they're going to say, see, everybody moved to the cloud. Yeah, you kind of pushed people into that.
Mm-hmm.
Then there's this affects the way that your decision process works. For example, when you're looking for solutions, say for security, for example, and you're forced into move to the cloud, you're now looking for solutions that are compatible with your cloud provider. That limits your choices. That might affect the ability that you have to find software that works both on the cloud, on your specific cloud provider, and with the stuff that you still have on premises. The other thing is that it will inevitably force you to change the stuff that you already have running. You can't just take a given line of business application and shoehorn it into a Kubernetes cluster. That's not how things work. You're going to have to do more development work. You're going to have to waste more money on new stuff that you need to code, and then you're going to have incompatibilities, and then stuff is going to break. All because you need to move to the cloud, and you heard that the cloud is where every company is at the moment. If you recall that story about that UniSuper fund in Australia that lost their Google Cloud stuff.
Right.
When they came out with that statement, yeah, we're on the cloud, we lost this, it was a 1 in a million thing, it's really bad, but we had a backup, so we restored stuff, and we have our cloud presence just like these large companies do. And then they proceeded to list a few large companies. They had no good reason for it. That's why they used that argument. Yeah, we're here because of the other ones. They had no compelling reason to being there other than, yes, look, the others are there, so we're there as well. And that's really, really a bad way to justify your decision process. Then there's the obvious aspect. It's not cheaper. The draw of the cloud has never been cost, even if it has been marketed as such. You only pay as you go. Yeah, but paying as you go racks up really, really quickly. Forget about that Amazon instance running for a couple of weeks, get hit by a bot, and your bill is gonna go through the roof.
You mentioned that, but I have yet to audit a company's cloud bill and not save them $10,000 within an hour. I am not kidding you. There's that many things that are overlooked. And I go in there, there's the obvious things I check, storage being one, snapshots, backup retention, things like that. It's insane. And they just let it accrue backups over like 4 or 5 years, never aging them out. And then they watch their bill climb. And I go in there, yeah, here's $10,000 a month in savings. I could pay for my own services with basically, unless that it costs me an hour, I find 10,000 in savings. But the reason I'm bringing this up is because everyone is moving to the cloud, but they're not really doing a good job with it. They're letting things go. Things are open that shouldn't be. They're not really setting a good example.
And what really drives me crazy in this situation is that when you go up to people and you try to explain that position, and that company is already set in moving to the cloud, they start looking at you sideways. What? You're crazy. What are you talking about? Everybody's in the cloud. Of course we're going to go to the cloud. And then they're going to start making those mistakes you just mentioned. And then they're going to start seeing the problems. And then after a couple of years, they're going to start looking at ways to move out of there. And somebody's saying it's the data egress cost that's a killer. Yeah, it is.
Yep.
And it's also the transfer back that's a killer. And it's the fact that you need to find a compatible alternate provider that lets you migrate from one to the other, or a way to move back into your own on-premises stuff. if you recall, when Azure started, they would send out these cards loaded with hard disks to your data center where you could physically copy the stuff over and then ship it back, and then they would feed it into their own systems because it would be faster than the network connections that were available at the time. That's still the case because data usage has exploded. That will always be the case. So you will always be bottlenecked by the network connection. Consider that when you're looking at huge amounts of data that need to be migrated, not just to the cloud when you start considering moving there, but when you're starting to move back. You need to actually start thinking about that if you're in any way considering a cloud move.
I think the thing that really is funny to me is when a company switches to something for the sake of switching to it, and then they come back and they say, well, we have to stay competitive. Okay, if they're an IT company, I get it. But if let's just say they're a bookseller, right? How does having cloud make the authors write better books? Or, they're producing this product or that product. They're staying competitive by releasing a product that the public wants, and then they're competing with other companies that do the same thing. All the IT stuff, that's behind the scenes. Nobody sees that. The customers don't see that. And you're telling me how you do things in secret behind a closed closet door is staying competitive when no one even knows what you're doing in the first place? It's just the weirdest argument that they can make in favor of that. It's just odd.
The one argument that they make that it's not hard to counter, but it has some weight behind it. It's the explosive growth that you might have. If you have a sudden surge, a sudden spike in traffic that you need to handle, the cloud can supply that. But you need to consider as well that how many companies do you know have ever had that surge in traffic, have ever actually needed that? Do you know of any example? I don't.
I do, one, but it's not many. It's more to your point. I can't say the name of the company, but there is a company I've worked with that has they're in a cloud and they have auto scaling to where they have 3 servers, and then it could go up to like 20 if they have a software release. But we're talking about very specific industries. Like obviously, if you're releasing a software product, you're going to have more downloads the day of release, but you're not going to keep those servers 24/7 if you only have a boost whenever you release. So in that case, that's a very good use case for it.
Because if that spike becomes permanent, if you're always having those spikes, then it's not a spike, it's just your traffic that increased, and you need to plan accordingly to that. It doesn't matter if your cloud provider can help you in explosive growth, because that's not your problem. Your problem is that your traffic increased, and that's it. You need to account for that.
I think I was just going to say, I think for me, it's when companies decide to move to the cloud to stay competitive, they've made that decision before they find out that the cloud can scale. As soon as the white paper says everyone's moving to the cloud, they're not looking at the features. They don't care about the features. Other companies are doing it. My boss is going to be upset with me if we're not competitive. Let's get it done. And then they find out that there's all this scalability and all these extra features they could benefit from. So it's like, even though there are features that can lower cost of ownership, I just don't think that's the reason why people are doing it, for the most part.
Yeah. Again, it's a solution looking for a problem other than instead of something else. Someone is mentioning license costs. I believe what React End is talking about is license costs if you go on premises and you have to handle them yourself. That's true, and VMware price increases, that's a real issue. But don't by a second imagine that you're not paying those license costs when you're hosted on the cloud, because it's part of what you're paying. And if your bill goes up unexpectedly, it's because the license costs for the cloud provider have gone up as well. So they are passing that cost to you. So you will be paying your share of that cost regardless of being on premises or not. With the advantage that when you're on premises, you have the option of changing your virtualization provider more easily than when you're on the cloud. But again, that's getting into the nitty-gritty of things, and I really don't want to get in all of the details, or we will be here for hours.
That is very true.
So this is one data point from that particular study, the Uptime Institute's Global Data Center Survey 2024. Again, I promised I wouldn't bore you with the details of the study. This was just the number that really popped up because it has been a pet peeve of mine for many, many years to see company after company move to the cloud without a clear path on why they want to get to the cloud and what they're going to do when they're there, and what benefit they're going to reap from being on the cloud rather than on their own devices, on their own equipment, on their own data center. And finally, I can bet anyone on the audience that I can run downstairs to the data center and plug the network cable faster than you can log into your cloud provider's panel, find the right VM, and shut it off in case of a problem.
That is very true. Yeah, it takes longer to log in to your cloud provider than it does to do that. You haven't even reached the console yet, and you've already beat them. So,
okay.
so do we want to talk about Jenkins now?
Yeah. Next, we have a couple of CISA warnings, and they're warnings about two different bugs. Let's start with Jenkins, our favorite automation tool. It's for continuous integration and delivery. It's a tool used on development environments, and not just that. And it turns out that it has a vulnerability that makes it possible for remote attackers to read arbitrary files that are contained within.
Mm-hmm.
Why is this so interesting? It has actually been published some time ago, and it's now making the rounds again because CISA has added this specific vulnerability to their known exploit list, meaning that CISA knows that this is being exploited in the wild. CISA is the Cybersecurity and Infrastructure Security Agency. It's a US agency that handles this type of things, and they have this list where they have hundreds of vulnerabilities that are actively being exploited in the wild and that you need to pay particular attention to. And this one just made the list. It's also relevant because by being added to that list, it started a timer to federal agencies in the US in which they have to apply patches to it. In this case, they have until September 9th to have this patched, or else they will be missing out in a directive somewhere, and they can incur some problems because of that. So yeah, if you have Jenkins on your infrastructure, like many do, you really need to make sure that it's up to date, or else somebody else might be reading your files.
I was just going to mention a lot of people in my audience have Jenkins installed, not just because of its popularity. I did a tutorial about it not that long ago, so I got some people on that. So especially if you use my tutorial, installed it, just make sure you install your updates. That's always the case, but Jenkins is especially bad because it's a CI/CD system. This is how development integration happens, and the last thing we want integrated with our code base is malware, and obviously this is a directory reading vulnerability, but already that gives threat actors a lot of information. Like if they could read even if they can't get in via SSH, if they could read your SSH config file, they know what options you've set. So if you missed one that you should have set for security purposes, they'll see that. They could see what security settings are in your Apache file, Nginx, whatever it is. They could find some, even though I'm not sure that it gives them remote access, I think it will lead to that, right? Because they have access to all the open source intelligence they could ever need by just going through the directory.
I mean, if you can read what's in the build pipeline, you can probably find some secrets before they are cleaned out of the code. You can probably find some source code directly that you might be interested in. All kinds of nasty stuff, even if it doesn't give you remote code execution. What
API?
does give you remote code execution is the next one, which is another CISA warning, this time for SolarWinds web help desk tool.
Such a clever name.
Such a clever name. If SolarWinds sounds familiar and you don't know exactly, it's because it has a vulnerability every other week. Remember that time a couple of years ago when they were infiltrated by, at the time I believe, Russian hackers, and they managed to get into Microsoft and government and many different types of places because one of SolarWinds tools had been infected with malicious code. This time, their web help desk tool is subject to remote code execution. It's also on CISA's known exploit list. And if you're on a government agency, you have until September 5th to patch this, or else you'll be missing out on stuff. and it's really, really bad. It's remote code execution. Those are never fun to have, and this one is just nasty.
Remember when Java used to be the butt of all security jokes, where like the majority of the vulnerabilities impacting enterprise was something Java related, and then Steve Gibson on Security Now said something like "write once, exploit everywhere," a play on their slogan. I feel like SolarWinds is becoming the new Java at this point.
I mean,
Not the same thing, but they're in use in the enterprise, just like Java, had a big imprint and probably still does on the enterprise. And now the target's on their back, just like the target was on Java.
The Jenkins story, the actual bug was in a Java library that they used. So yeah,
Of course,
it's not like Java is missing.
Right.
But yeah, SolarWinds has a really huge target painted on their backs. At this moment, they should be looking at security a bit harder than they are, because they have suffered problems like this so many times. This is like a scratch record going always on the same track. Yeah, it's another one. You have to update the tool if you use it. Keep in mind that the hotfix that was released, if you use single sign-on with it, don't apply the hotfix, the first one, because it will break single sign-on, and you really don't want that either. So yeah, pay attention to new versions that are being released for the web help desk tool. You really need to update, but update to one that doesn't actually break the application directly.
Right. Yep. And meanwhile, it's still hard to get people to submit tickets in the first place. And now we have to manage to fix the thing that people aren't putting tickets in, I guess.
Okay, so remember when I said at the start of the podcast that we would get to the Windows users? This is the final story. Microsoft warned their customers to patch critical TCP/IP code remote code execution vulnerability that targets IPv6. The fun story here is that for many years now, IPv6 is enabled by default on every single NIC that receives that is on a Windows system. So if you haven't explicitly disabled IPv6, you really need to go running and take it out, because it's remotely exploitable. Just blocking IPv6 on the firewall, doesn't fix it, because the vulnerability happens before the packets hit the firewall. So it's very early in the network stack. It allows for remote code execution, and Microsoft is warning that they expect hackers to create reliable tools to exploit this at will. This is really, really bad. It impacts all Windows versions that run IPv6, which are basically all of them.
Yeah, it's IPv6 is the Oprah of IPs. You can have an IP, you can have an IP, everybody gets an IP because there's a non-limited number of them. But it's interesting, like I disabled IPv6 on my end probably more than 5 years ago, because it's just surprising to me that companies use it internal when ISPs need this because there's so many internet subscribers out there. But I don't think anyone has the devices on the inside of the network that they would need to use up all the. I mean, if any company would have, what is it, like I have no idea what the number is. It's excessive. Nobody has a number of devices inside their network, but they moved to IPv6. And then meanwhile, there's other problems that IPv6 causes that we don't talk about. Now, we have this for the Windows people to deal with.
I mean, the decision from Microsoft to actually enable IPv6 by default on every single NIC, it's not misguided. It's not inherently a bad decision. They were trying to force the IPv6 adoption because nobody was using IPv6, even if it has been out for over 20 years now.
Right.
By the way, the reason why people don't use IPv6 is because IPv6 was designed for machines, not humans. But the humans are the ones that have to configure it. That's the entire problem of IPv6 right there.
Right.
If you ever find yourself in an argument over why people are not using IPv6, it's because of that. You can easily memorize 4 numbers, but you really have a hard time memorizing those many amounts of hexadecimal numbers. So Microsoft tried to get people to use it, even if people were not ready for it. So much so that they have documentation and they have specific services, and I'm looking at you, cluster service, in which they will try to force you to use IPv6 even if you could use IPv4 instead. They really tried to get people to use it.
They did, yeah.
It just turns out that it has problems like every single piece of software has.
It really does, and it's It's been the longest migration story this side of 16-bit to 32-bit that I've ever read or seen. It just takes forever. But here we are. But yeah, patch
Probably
your.
longer than that.
But also, one really important thing in the article is that it does clarify this is a wormable vulnerability.
Yeah, and it's probably good if we spend a minute on that. What they mean by wormable means that it can be remotely exploitable, and it lets you run whatever code you want after it gets exploited. So you can code a program that exploits the vulnerability, copies itself to the new system, and then executes again and looks for other targets. That's what the worm is. It replicates itself, and it can look for other targets on its own. We've had quite a few instances of Windows-based worms, like Nasser a few years back, many years back. Blaster, I believe, as well was the name of another one. Nimda, yeah.
Yep.
And they have always been really, really tricky to eliminate completely. As soon as you have one system infected, another one starts to be infected, and another, and another, and another. And the places where this is especially difficult are large companies, where you have workstations that are running Windows, and as soon as the first one gets hit, all the workstations will be hit as well.
Oh my gosh. I really hope nobody is recovering from the recent outage that everyone dealt with just to deal with this right after. I mean, that would be horrific. I do not want that to happen to anyone.
It could actually become a problem on that scale,
It can, yeah.
Most firewalls out there are not configured to block IPv6. You might have protections for IPv4, you don't let other addresses reach your system, but not as many people configure IPv6 firewalls as they do for IPv4. And not all of those people, of those persons, will realize that they have IPv6 listening and probably have services exposed on IPv6, and they don't really understand that IPv6 is routable even if you don't have NAT for it, and the traffic can hit you. Other ISPs, on the other hand, they won't even route IPv6 to your modem. I have a couple of them back here. None of them receives IPv6 from the ISP. So, yeah. Also, and I was almost forgetting this, if you have Windows systems, fun fact, you can have IPv6 traffic reach your system even if your ISP is not routing it, because it can be tunneled inside IPv4. So pay attention to that. And if you have IPv6 open on your NICs and you're not aware of it, take a look and disable that checkbox.
I think at some point this bug notwithstanding, that there's going to be an issue that's going to label IPv6 as a backdoor. And not that it's a backdoor in and of itself, because it's not. It's always how it's implemented, how you treat it, how you secure it. And with most administrators knowing IPv4 backwards and forwards, but they don't know IPv6 as well, then they're not going to know as many things they can do to help secure it, which would automatically make IPv6 weaker, in my opinion, unless the administrator is just one of those gurus that just happens to know both. But more often than not, it seems like everybody knows IPv4, but IPv6 is just that thing that is there and sits there and no one looks at it.
There is one thing with IPv6 that I never understood. There's so many IPv6 addresses available, and yet there is this portion of code in the Linux kernel that is IPv6 NAT. I never understood why the hell you need NAT for IPv6 when you have millions of addresses available. And you have this module that you can configure on the Linux kernel for IPv6 NAT. I never actually spent the time or looked up the documentation. I'm sure there's some justification for that. It's just mind-boggling that it exists. I mean, for NAT, it's for IPv4, the reasoning of why it exists. You have more machines than you have IPs available. You have to have some way of masking that. But for IPv6, it doesn't really make that much sense. You're never limited by addresses.
Do you think there's any kind of compatibility in carrier grade NAT that would require some kind of compatibility in IPv6 to make the conversion? It's just a guess on my part, because I know, for people that don't know, carrier grade NAT is essentially if an ISP, this isn't the only reason they don't want to move to IPv6. They kind of put their subscribers behind one IP address to kind of save IP addresses. But if that's routable to IPv6, I was just wondering if there's something at the higher level than us, like we're talking network pipelines and things across the world. But yeah, you're right. That is interesting. I'm going to have to look at this and find out.
Yeah. Again, never really understood it. It always pops up when I'm looking at modules to configure, and I always find it fascinating that it's there, but I'm also always busy with something else that I'm trying to do, so I never spend the time. But
it's amazing
it's
what
boggling.
you'll see when you look at something really close. You start looking in the code. Like I was one time a couple of years ago, just in the trenches of dconfig in GNOME, and I found that there's a hidden feature where you can name your desktops. That's not exposed in the extensions tool. It's not in the settings, but a totally hidden feature where you can name your workspaces. And it was put in there like they were going to develop it, and then it's gone. I mean, you never really do know. I mean, when a company I worked for, the code base had a comment that says activate this to activate kitten mode, and I never did get to activate that before the company went out of business. But if you look at the code base, you'll find some interesting things and wonder why they're there for sure.
Yeah. So I guess this covers the stories that we wanted to go over today. These were the ones that caught our eye for the weeks that we were away on vacation. Thanks to everybody who joined. As always, it was a pleasure. And until the next one.
I also want to mention to everyone before I forget, I will be at a 45 Drives event next week. So I'll be actually out next week, but I'll be back the week after. So,
and
I wanted to let you guys know.
Because you were going on a tangent there, I just want to say congrats on the 700K, Jay. It's been a pleasure being part of the podcast with you, and it's a pleasure seeing you past 700K subscribers.
Thank you so much. I really appreciate that. It just blows me away that it's doing that well. It's just kind of incredible, and it still doesn't even feel real, but I think it's awesome. It's a lot of fun. So
thanks, everybody. Again, it was a pleasure.